So our group has one missing person. Chelle Gentemann had to leave early for her flight. So we have an invisible Chelle here who had to leave, but she was kind of part of our group. But our general goal is kind of broadly, we want to get more familiar with taking data remotely from the cloud, particularly work with chlorophyll data, and see kind of what we can do with that, because we haven't really worked with remotely accessing data. We just want to build some tools that we could play with. So we have kind of a set of notebooks we have on our repository, but kind of the main idea in this first one was just building up a set of tools that we can use to actually bring them in, and kind of make them a little more generic, so you can kind of make it a bit more user-friendly. You can choose which data set you want, so which resolutions you're pulling through, exactly which variable types, which algorithms you want. And then it goes through and just kind of parses them all in and does a bit of lazy loading. There's a bit of kind of kludgy for looping hackiness. The main issue being is the data sources don't have a time dimension in any of the variables. You have to kind of load them in a kind of a separate way and then forcibly re-add time to each one, and so you can stack them. But I have to use a little bit of data cleaning, which is kind of mostly bundled together. You can go through and pull it in, then start to actually do just a bit of science on it. So we try to get the data loading and cleaned up and tucked away, so you can then start just playing around with kind of simple data things. So see how chlorophyll evolves as kind of over a year, or kind of averaging over time, and making fun kind of spatial plots of things. So the idea was to try and get all this data I/O part, try to make it user-friendly and hide the kludgy bits, so you can just kind of take that in and start trying to do science on it. We then want to extend the science bit with just kind of taking some more tools. So I had a previously built tool that I'd used with just a finite diff package, which it can actually be pip installed through a package called SpinSpy. The idea is you give whatever grid you have, you say what order accuracy you want. So if you want, a third derivative to 7th order accuracy, it says, here's your derivative matrix. So we go through, we can load in our data, and we want to say, how does our gradients in chlorophyll compare to, say, gradients in sea surface temperature? This is one of Chelle's ideas. So we load in our data as before, we subset our data, kind of go through, do some calculations. All we really care about is the science here. And of course, run into the problem that data is not perfect. Particular clouds exist. If you have satellites, clouds get in the way. And if you're taking derivatives and you have missing data points, that causes issues. You can technically get around this by using a shifting derivative stencil, but that takes a bit of care. So the laziest approach is, if you have, say, a month worth of data, so on the left, the idea is take your month worth of data, take your gradients, then average out. As long as you get some flaky, noisy bits from where the clouds were. If instead you average first, kind of average out your cloud garbage, and you can get much cleaner gradients. So kind of spatial gradients, magnitudes of chlorophyll locally. We repeat the process, load in sea surface temperature data. We can try to compare, fly through these. So we're kind of comparing, if you take your chlorophyll spatially on the left and density on the right, and then take some gradients of them, how do those compare? So gradients to the mean, let's try to see how can these match up. Original goal was to do time correlations, but we could only load in about a month of data before the kernel crashed, and a month of data is about as much as we need to average out to get rid of clouds. So there are currently no time correlations, but yeah, we kind of got to do some of the fun things we wanted to do by loading some data, doing a little bit of science. You do get some coastal artifacts just because, again, the stencils overlap with missing data spots, and the derivatives get a little unhappy. I'll switch to a light background for these graphs. Here.
Yeah, and so like Ben was saying, so all the data comes for the chlorophyll from the satellite comes from the NASA Ocean Color Web, and there are a lot of really great tools out there. I think it's called getoc.py. I don't remember off the top of my head, but basically that other people have written, which will pull data off their server and you can download it. And so what we were trying to do is how can we basically get data from the website and get it from the cloud. So we use the OpenDAP instead, which hosts the level 3 data. So if you're interested in like level 1 or level 2, there are other codes out there. And there might be one that also does it in the cloud and we just don't know about it. So if there is, let me know. And so that was a cool, what we think was an addition to what didn't already exist. And so this was a code that was written by other people, and Chelle has since modified it for basically just building a tutorial where if you have different, so it started with matching sea surface temperature data from a different satellite and matching that with sail drone crews. And so then we, for this project, added in the chlorophyll from the Modus Aqua. So yeah, just loading in some of your utilities. And so then this reads in the sail drone data, which comes from the PODAC. And we also got the sea surface temperature data from PODAC. And so you basically input the start and end time, which in this case were the cruise dates from the sail drone, and subset. So then we can pull in, yeah, so this is showing the track of the sail drone with chlorophyll. And so then we're pulling in the data from the Modus satellite to add on the ocean color observations. And so this comes from the code that Ben was just explaining. So there's, it just pulls out some of the, you put your user inputs, and then you can download the overlapping data from the opened app. And this is like what the full global level 3 chlorophyll is. So there's a lot of spots in your data on that one. And then this is taking sea surface temperature, also from the PODAC. And this is, we first started with a MER satellite. The code originally was to work with MER SST. And it's a 0.01 degree resolution, which crashed the kernel. So we used a different data set instead, which was 0.1 degree. And so that's something that, working on this in the future, a really good project would be like maybe incorporating Dask and having it run more efficiently, so that like all of the ideas that were in this code from when we started editing it and things that we added in could be improved to run more efficiently. But the ideas are all there in a format where someone could, like me, who really didn't know much about this before, could take it and learn from it, and then be able to get at the science questions. So this is the SST data globally. And so we wanted to then basically subset all of the data so that it just, before loading it into the workspace, you're only taking the Latin long, like the values that you actually need in order to be able to overlap with the sail drone. So this is a subset SST and subsetted chlorophyll. And then the next part of the code is also something that can be improved in the future, but now that we know there are many different ways to, like group earlier was tracking the sea turtle, so taking some sort of like trackpy, and this is just doing 2 different types of interpolations to match the sail drone locations and time and space to the satellite. And so you can kind of then compare, I don't know how to make it smaller. So this is like basically comparing the interpolation methods for plotting the sail drone track with the sail drone observations compared to the satellite. So the really idea of this is you can kind of learn and work through how you would maybe pair some in situ data with some satellite observations, and it could be adapted in through a lot of different data sets.
I did something somewhat similar in talking to. Oh yeah, in that I was also working with kind of extracting and working with publicly available data, but I work with a lot of OOI data. So For the last 9 months or so, I've been using the data portal to abstract my data, and about 9 months late, I'm switching to a new method. I experienced the pain of doing that. As Tim mentioned during his talk, it's not that friendly, so I'm going to go through extracting using M2M, the M2M interface. It's relatively straightforward. I'll just go through some of the highlights really quickly. So the only time you need to visit the data portal itself is to create an account. Then you can enter your API credentials and progress from there. There's a really handy website that I did not know about called the Data Team Portal. Can I click links? Is that all right? Here. You're gonna have to help me get back. But yeah, this is just like kind of a more user-friendly way of accessing the instrumentation. So if you want to look for a meteorological instrument, you can click in and view some of its kind of uptime or availability on both a daily and monthly basis. How do I get back here? Cool. Yeah, so second step, you enter those credentials from the kind of data portal website, or sorry, the instrument information. And then you select kind of a date range and options. By entering this limit here, you're indicating that you would like it in JSON format, and you're restricted to about 20,000 data points. And then your request from the thread server. One interesting thing about this, you'll receive an email after requesting, and in that email you'll receive a link to the threads server. If you take out the instrument information in that link and just use the catalog HTML, you'll find a full kind of list of all the requests you've made. I had it on my other computer, but I recently found that out, and I have months worth of requests that would have been really helpful to know about that by now. But yeah, thanks to the people who notified me of that. And then just to kind of visualize an Altair, which is, a couple of people have mentioned it, it's kind of a visualization package developed here at UW that I'm slightly familiar with. I'll convert it to a data frame. Another helpful thing, if kind of sorting through these indices or these column headers gets kind of annoying, you can go back to that data team portal and find how they're all indexed and kind of cataloged here. And then yeah, the time format is in NTP seconds. We do a quick conversion. And lastly, I kind of ran out of time with the Altair stuff. Didn't get an opportunity to do anything too kind of creative, but here's a simple time series plot of irradiance data. And this is in the Southern Ocean, so the times that they have the most sun is the opposite of our months. So you'll see during our winter months, we have a lot of sun. We kind of confirmed that hypothesis looking at a histogram. Yeah. Nice and simple. And you'll see that during December is the time with the most insolation. I live here in Seattle, so you know where to find me come December. I'll be in the Southern Ocean. Getting some rays. I know, I'm making a joke. All right, thank you very much.
So that's great work, really nice. I missed the part of how programmatic about the data. Can you just go back to it?
So this one?
You did the credentials, right?
Yeah.
Sorry, the Altair one or the?
Yeah, I can go through that a little more in detail. Yeah, Friedrich helped me with this, so he might have something.
My heart breaks every time someone uses an FTP. It just happened twice, not that much figures. So when you have a better system.
Okay. Yeah, so I enter the credentials here and I create a data request URL through combining the information about the instrument with the base URL of the kind of, I guess, like OINet M2M reference link. And then from there, just using this request package, I get the data.
Yeah, with the URL, would the URL package that Tom mentioned here, when they help with that?
So, sorry?
The unified package that Don commented here last Wednesday, would that help in any way?
I'm not sure. I'm not too familiar with it. Can anyone else? Would you like to answer? Or yeah.
Do I have more questions? Oh. Let's get that next one.
Okay.